Welcome back to The Explainer. Today we're revealing how the absolute most high-stakes phase of building a massive ship happens entirely on paper, long before a single piece of steel is ever cut. Look, when we talk about shipbuilding, we aren't talking about slapping a canoe together in the backyard. We're talking about multi-million, sometimes multi-billion-dollar megaprojects. These are literally floating cities. They've got power plants, heavy machinery, and intricate infrastructure all wrapped up in a giant steel hull. And getting from contract to construction requires an incredible, high-pressure planning process that completely dictates whether this colossal investment succeeds or sinks.
Okay, here's our roadmap for today. 1. The Invisible Project Foundation. 2. Immediate Actions and WBS. 3. Engineering and Procurement Planning. 4. Block Construction Strategy. 5. Managing Risks and Stakeholders. And finally, 6. Preparing for keel laying. Let's dive in.
So there's this powerful baseline truth in shipbuilding that we really need to anchor ourselves to right off the bat. The success of a project is often determined long before the first piece of steel is cut. This initial phase, it sets massive stakes for the entire early planning window. The time you invest here yields immense returns throughout what is usually a years-long construction period. It's quite literally a make-or-break window where the ghost of the final ship is already being tested against reality. All right, let's jump right into part 1, the Invisible Project Foundation.
You know, this period between signing the contract and laying the keel is actually pretty short compared to the overall project timeline, yet it's disproportionately important. Think about your own projects for a second. How often do you just want to rush straight into the doing phase? The temptation to immediately show some kind of visible progress is just human nature, right? But rushing this invisible short window is exactly what plants the seeds for future material shortages and massive schedule slippages down the line. In the heavy shipbuilding industry, mastering this discipline is called front-end loading. It requires immense patience to understand that acting without comprehensive analysis almost guarantees devastating, incredibly costly problems later on. You absolutely have to finish the blueprint before you pour the concrete.
Moving right along to Section 2, Immediate Actions and WBS. Okay, so the ink on the contract is dry, the clock is officially ticking, and the day 1 sprint begins. Executing this rapid-fire sequence flawlessly is absolutely mandatory. Step 1 demands pulling together your core brain trust instantly, your project manager, planning engineer, procurement lead, quality assurance reps, the whole crew. Step 2 gets everyone into a room to establish rigorous communication protocols. But Step 3? That's where the real detective work happens. The team actively scours the baseline specifications to catch potential risks, hunting for ambiguities in the contract before they blow up into total disasters. Imagine what happens if a tiny discrepancy in a pipe specification isn't caught right now. Months later, hundreds of installed pipes might have to be completely ripped out. Getting the owner's expectations perfectly aligned on day 1 is literally the only way to prevent massive, paralyzing change orders on day 300. Now, you simply cannot manage a mega project without chopping it up into digestible pieces. And the work breakdown structure, or WBS, is exactly how you tame that overwhelming complexity. Think of the WBS as the ultimate translation layer between the engineers drawing the ship and the welders actually putting it together. A beautifully designed structural drawing is completely useless if it doesn't match how the shipyard naturally operates. A well-structured WBS directly aligns the ship's components with the shipyard's specific production methods. This ensures that every single department, engineering, procurement, construction, are all speaking the exact same language from day 1. Which brings us to Section 3, Engineering and Procurement Planning. This phase is where it gets really intense. It's essentially a high-pressure race between the blueprints and the shopping cart. You need your basic design finalized, followed immediately by detailed structural block drawings, piping layouts, electrical systems, and your comprehensive bill of materials. It's a brutal domino effect. Late design deliverables act as the absolute #1 culprit for workshop delays down the line. The engineering schedule has to aggressively, almost obsessively, support the production requirements. If the detailed piping drawing is just a single week late, well, the specific materials can't get ordered. And if the materials aren't there, the welders stand idle and the entire multi-million-dollar assembly line grinds to a devastating halt. Everything is connected. And why is that timing so intensely critical? 2 words for you: long lead items. This is such a fascinating micro-narrative within the giant shipbuilding process. Consider the sheer anxiety and the precision required to order a multi-million-dollar main engine, a massive boiler, or heavy deck machinery literally years in advance. These gigantic pieces of equipment have their own massive manufacturing and delivery timelines. That means any late design detail up front can completely derail your final delivery. You have to identify these long lead items immediately upon contract signing, locking in exact order placement dates to align with a construction schedule that hasn't even started yet. All right, let's look at Section 4, Block Construction Strategy. We aren't just building a ship in one piece here, we are solving the ultimate 3D puzzle. The shipyard must lock down the sequential puzzle of how materials flow from the workshop to the building dock super early. This creates the absolute basis for all resource planning. Modern ships are built by constructing giant blocks separately and then sticking them together. But you've got to consider strict physical limitations. For instance, pre-outfitting is this highly efficient practice of installing pipes, cables, and smaller machinery into a block before it's ever welded to the rest of the ship. It saves huge amounts of time. However, if your shipyard crane can only safely lift 100 tons, you literally cannot design a block that weighs 120 tons once all that pre-outfitting is added inside. Calculating this exact erection sequence is everything. Next up, Section 5, Managing Risks and Stakeholders. Building a massive vessel means wrangling an incredible number of unknowns and external forces before they completely destroy your perfect plans. Centralized project management portals are essential for establishing a robust risk register the absolute second the contract is signed. You have to continuously track and mitigate two entirely different fronts. On one side, you have technical threats, like, say, a new unfamiliar propulsion design simply not working as expected. On the other side, you have commercial threats, like a critical steel supplier suddenly going bankrupt halfway across the world. A proactive management portal ensures you have mitigation plans and contingency strategies locked and loaded before those threats ever materialize. But hey, the best software tools in the world won't save you if your communication is broken. Establishing clear communication channels, defining exact approval processes, and aligning on major schedule milestones is critical. And a huge part of this is coordinating with the Classification Society. If you aren't familiar, a classification society is an independent organization that sets and maintains the strict technical standards for the construction and operation of ships. They are the ultimate referees. If you don't align expectations with them and the owner right off the bat, misunderstandings will completely rupture your timeline. Everyone involved needs to know exactly who approves what standards apply, and precisely when the green light is given. And finally, Section 6, Preparing for Keel laying. So the finish line of our massive planning sprint is actually the starting line for the physical build. True readiness means these underlying requirements, completed engineering deliverables, physical availability of the bottom structure steel, prepped production facilities, and all secured approvals are strictly met before a single crane moves. Skipping even one of these prerequisites is disastrous. If you start building before all the steel is available, workers are forced into these inefficient workarounds, jumping between different sections of the hull just to stay busy. It completely ruins efficiency, compromises quality, and dramatically inflates costs. Now, there is this constant, incredibly stressful tug-of-war in shipbuilding between optics and reality. On one side, you have the keel laying ceremony. It's a fantastic, highly symbolic public relations event that generates huge excitement, but it also creates immense pressure from executives or stakeholders to start physical construction prematurely just to capture a photo op. On the other side, you have rigorous, invisible technical readiness, the unglamorous completion of engineering and physical material availability. The source material issues a very stark warning here. A symbolic event should absolutely never be used to pressure the engineering and production teams into starting construction before genuine, rigorous technical preparation is 100% complete. The quality of planning between contract and keel laying is undeniably one of the strongest predictors of overall project performance. A ship's fate truly is sealed before the real construction even begins. As we wrap up this explainer, I want you to take this lesson from the heavy industry of shipbuilding directly into your own professional life. Think deeply about it. Are you building your own projects on a solid, thoroughly planned, heavily front-loaded foundation? Or are you rushing straight to the dry dock just to look like you're making progress? Keep that in mind for your next big build. Thanks so much for joining me on this explainer, and I'll catch you on the next one.